Looking up at the night sky might give you the impression that the cosmos will endure eternally, with stars living and dying in perpetual cycles. The truth is far more sobering. Consider the Milky Way, spanning up to 200,000 light-years and home to somewhere between 100 and 400 billion stars. How many new stars do you think form here annually? 1,000? Perhaps millions? The actual number is roughly 3. That's right, just 3 stars per year. Remarkably, 95% of all stars destined to exist in our universe have already formed. We're witnessing the twilight of stellar creation, standing at the threshold of cosmic endings. Star formation will gradually dwindle, but the story gets more complex. The universe itself is rushing away from us at accelerating speeds. The Milky Way doesn't exist in isolation. Along with Andromeda and over 50 smaller dwarf galaxies, it forms what astronomers call the local group, a cosmic neighborhood measuring roughly 10 million light-years across. Hundreds of similar galaxy groups combine to create the Laniakea supercluster, which itself represents just one among countless superclusters. In total, approximately 2 trillion galaxies comprise what we currently observe as the universe. Here's the startling reality, though. Even if humanity could somehow travel at light speed, about 94% of visible galaxies have already drifted permanently beyond our reach. Let that sobering statistic settle in your mind. There exists a definitive boundary to our cosmic domain, and vast stretches of universe will remain forever untouchable. It's genuinely unsettling when you contemplate it deeply. What makes these distant galaxies unreachable? The answer lies in how galaxies came to exist in the first place, tracing back to the Big Bang itself. Without overcomplicating things, approximately 10 to the negative 36 seconds after the Big Bang, our infant universe existed as an incredibly tiny bubble of concentrated energy. This primordial bubble wasn't perfectly uniform. Certain regions contained slightly more density than their surroundings, a seemingly trivial difference that would prove monumentally important. During what scientists call cosmic inflation, the observable universe underwent explosive expansion, growing from marble size to trillions of kilometers across within a trillionth of a second. This mind-boggling expansion stretched those microscopic density variations across galactic distances, creating the more dense and less dense regions characterizing the universe today. These denser pockets contained slightly more material than surrounding space. When inflation ceased, gravity started pulling everything back together. Within the denser pockets, gravity won this cosmic tug of war, eventually forming galaxy groups like our local group over billions of years. The local group represents our pocket of cosmic real estate. At larger scales beyond these denser regions, however, spatial expansion never stopped. Our local group finds itself surrounded by numerous structures and galaxies, but none share gravitational bonds with us. As universal expansion continues, distances between us and other gravitational pockets constantly increase. The situation grows more challenging because universal expansion is accelerating. Scientists don't fully understand why this happens, so they've proposed dark energy as an explanation. Think of it as an invisible force driving faster expansion. These concepts deserve deeper exploration in future discussions, but for now, understand that the universe expands at increasing rates. This expansion creates what's called a cosmological horizon surrounding us. Everything beyond this boundary travels away faster than light speed relative to our position, making it irretrievably unreachable. It functions similarly to a black hole's event horizon, except it encircles us completely. 94% of currently visible galaxies have already crossed this threshold, lost to us permanently. You might wonder how we can still see them if they're beyond interaction. Light provides the answer. Although light travels at the universe's maximum speed, It requires time to journey between locations. Every second, light arrives from trillions of galaxies that have passed the horizon because when their light was emitted, they were much closer. We're observing their ancient past and earlier positions. The observable universe, therefore, appears much larger than the universe we can actually interact with. The cosmos presents us with an elaborate show, displaying things permanently out of reach. We'll never know what these galaxies look like currently. Interestingly, this means the observable universe continues appearing to grow as light from super-distant galaxies, released billions of years ago, finally reaches our telescopes. Eventually, though, all cosmic pockets outside the local group will pass our cosmological horizon. Once that happens, their light can't reach us anymore, and they'll fade into darkness from our perspective. Every second, 60,000 stars cross the horizon. Since you began reading this, approximately 22 million stars have moved beyond our reach forever. If 94% of the observable universe has passed the cosmic horizon, that leaves 6% technically reachable, which still represents tremendous amounts of cosmic territory. All galaxy pockets within 18 billion light-years remain accessible, though they're still receding. The chances of reaching them diminish every second. Everything beyond approximately 5 million light-years is moving away, but the nearest galaxy groups recede slowest, creating a time window to jump between galaxy groups. The challenge is extreme, even for highly advanced civilizations. Even at light speed, traveling to the Maffei group, the closest galaxy pocket outside the local group, would require 11 million years. If some exceptionally motivated, advanced civilization accepted this challenge, their potential sphere of influence could encompass hundreds or thousands of galaxies. As time passes and the universe grows, they'd eventually be separated forever. It's reasonable to assume humanity won't make this journey, at least not with any remotely foreseeable technology. The local group likely represents the largest structure we'll ever inhabit. Just traveling between stars would constitute an epic achievement. We'd be incredibly successful colonizing our cosmic backyard, which accounts for an infinitesimally small fraction of the observable universe. As dark energy pushes the remaining universe away, the local group will become more tightly bound. All its galaxies will eventually merge into one giant elliptical galaxy, unimaginatively named Milky. In a few billion years, this process might smash enormous gas clouds together, reigniting star formation temporarily. This new light will be welcome because eventually, galaxies outside Milky will become too distant and faint to detect. Once this occurs, no information beyond the local group will reach us again. The universe will recede from view entirely. A being born in the distant future within Milky will believe the universe contains nothing but their own galaxy. Looking into empty space, they'll see only more emptiness and darkness. They won't detect cosmic background radiation or learn about the Big Bang. They may have no way of knowing what we understand today about the expanding universe when it began, or how it will end. They might think the universe is static and eternal. Milky will become an island in darkness, slowly growing darker. Still, with its trillion stars, the local group provides a substantial playground to entertain humanity. After all, we haven't figured out how to leave our solar system yet, and we have dozens of billions of years minimum to explore our galaxy. We possess the incredible fortune to exist at precisely the right moment to observe both our future and our most distant past simply by looking at the night sky. However isolated the local group may be, it's our home, and it truly is a spectacular place.